So we're going to do a short lesson on solving equations that are quadratic in form. We were doing a series of lessons on quadratic equations and functions, and we're going to look at equations that are like quadratics, and you can use quadratic equation solving techniques to solve them. So I'm going to do a little recap here. Let's take a look at what a linear equation is real quick. Okay. You have a linear equation. You have it in the form ax to the first plus b equals 0. And this is your exponent, n is equal to 1. Your highest exponent in a linear equation is 1, which means you have up to one solution. Now an example would be something like 2x minus 1 equals 0. Okay, we know how to solve that. We get one solution. Now, if we look at what we've been studying, quadratic equations, they have the standard form, ax squared plus bx plus c equals 0. Here your n is equal to 2, and you have up to 2 solutions. Okay, and we know how to solve those fairly well. We solve them by factoring, square root property, quadratic formula, and completing the square. An example would be like a x squared minus 5x plus 6 equals 0. So that's a typical quadratic equation. So we have other kinds of equations we could apply some of the techniques to. So one of the things you want to note first is that you have up to n solutions for equations to the nth power. When n is equal to a natural number. Okay, so here we have the natural number 1. We have up to one solution. Here we have the natural number 2, so we have up to 2 solutions. So some equations I'll show you here. Some other n value equations. Let's say we had instead of 2, let's say this was x to the 4th minus 5x squared plus 6 equals 0. Okay, so here's one that's not a quadratic. It's up to the 4th power. So the question is, can we solve it? Yes, we can. So here we have up to 4 solutions. And you can solve using quadratic techniques. Okay, so you could solve this as well. So here I could just go ahead and solve this by factoring, and the only problem is I have to then try to factor my factors and get solutions for those. So there's one example. Another example is if I had, let's say, x to the 6th minus 13x cubed plus 36 equals 0. So in this case, what you have is you have up to 6 solutions. So here you have up to 4 solutions, up to 6 solutions, and again you can solve as well. You could solve it by factoring because it's like a quadratic equation. It has quadratic form, and this is quadratic form we'll look at. And the main idea there is that you could solve as long as you have 1, 2, 3 terms, and this term is half of your leading term. So if I take half of this leading exponent, I get 2. If I take half of this leading exponent, I get 3. So here we have this pattern. And then we just have our constant. So as long as you have that pattern, you're able to solve it like a quadratic equation, meaning you could solve it by factoring, which again is the easiest. You could apply the quadratic formula, and then you could also use square root property and complete the square. A little trickier to do those. Okay, so let's take a look at quadratic form. And see how we could apply this. Okay. So the idea here that you can solve any equation in what we call quadratic form. Which is our ax to the nth power plus bx to the n divided by 2 plus c equals 0. So here we have something in quadratic form. So what you want to note is that you have 3 terms that you need, and notice that the leading coefficient, the first term, has n on x, and the second term has half the leading exponent, which we call n divided by 2, and the third is constant. Okay, so the third term is constant. So here we have our typical quadratic form, and then when we recognize this, we could go ahead and solve. So the way we do, we solve by factoring. So what you have to do is then solve your factors. Quadratic formula. We could apply that, except then reduce your solutions and solve the roots that you get, etc. Some people use something called substitution to solve it, but I like to solve it directly. I like to look at what my factors are and then apply new solving techniques. So we have, now one thing is when n is a natural number, we have to add you have up to n solutions. Okay, but when n is not, natural, it just depends. So we'll start off with some simple examples. First, so here is your quadratic form, and it's important again to recognize these when you get them. So let's start off with one that's typically a little easier to solve. Let's say we have a problem, and it says solve And we have x to the 4th power minus 13x squared plus 36 equals 0. Okay? So I recognize that that is not a quadratic, but it's very, very similar to one. We can see that this 2, half of 4, equals 2. So there's my n, and that's half of my n's exponent, and then I have my constant. So I'm checking the quadratic form. So to solve this, I'm going to call this number 1. To solve, I recognize it's quadratic in form. And the first step I'm going to do is try to solve it by factoring. Okay, so let's go ahead and see how we can solve this by factoring. We have x to the 4th minus 13x squared plus 36 equals 0. Okay, now to factor, I want to find the factors that multiply to positive 36 but add up to minus 13. So those factors, positive 36, let's see, and up to minus 13, we have 9 and 4. That looks like that'll work. And they're both negatives. Okay, I could create that combination, that last term, with these two factors. Now the next question is, how do I get these terms to match up to the front term and the middle term? Well, here, as before, if you notice with the quadratic formula, you just take the square root of this number, and that goes in front. Or, in other words, it's always going to be the same as what your middle term variable exponent is. So if it's an x squared, we're going to end up with an x squared out in front. And luckily for us, in this example, there's no coefficients here to start with. So here, I just put in my x squared and my x squared, and I set that equal to 0, and I take a look at this and I say, okay, does that make my original equation? Okay, so here we have an equation, again, that's not a quadratic, but similar to one. We multiply these out, and we see that we get the original combination. Okay, so here I have my factors. Now what I want to do is set my factors equal to 0 and solve. So here I have x squared minus 9 equals 0, and then I have x squared minus 4 equals 0. All right, so typically in a quadratic, I just bring my number over and I'm done. I've solved for x, but here I have x squareds. So there's a little extra step involved. So now I want to solve each of these. So I say x squared equals 9. And to solve this one, I use my square root property. So I take the square root of the x squared, I take the square root of the 9, gives me a plus or minus, and I get x equals plus or minus 3. Okay, so I get two solutions out of that factor. The next factor I solve, I get x squared equals 4, and I take the square root of this side, take the square root of this side, and I get x equals plus or minus 2. I get another two solutions. So altogether, in this case, I get 4 solutions. So again, you get up to 4 solutions. So my solutions are going to be x equals plus or minus 3, plus or minus 2. And you could check those. You could plug in positive 3 here and here and check that you get 0 equals 0. Minus 3 as well, positive 2 and minus 2. And that should work. So there's our first example. And we're going to move up to a few more complex ones. Okay, so let's try one that has square roots. So number 2 let's go ahead and solve x minus 13 square root of x plus 36 equals 0. Okay, so this might not seem like it's quadratic in form, but if I write it the square root with rational exponents, I get x to the first minus 13, x to the 1/2 plus 36 equals 0. And if I rewrite it this way, I can see that this is 1/2 of my leading exponent 1. Okay, so n equals 1, and then half of it equals 1/2. So I have quadratic form. I'm checking for that. So I can go directly and try to factor this. And again, if I can't factor, by default, I go with the quadratic formula. So here, when I factor this, I want to again use my middle term exponent. So I'm going to get x to the 1/2 here, and x to the 1/2 here. And again, note that x to the 1/2 times x to the 1/2 by our rules of exponents give me x to the 1/2 plus 1/2, which equal x to the first power. So this combination will work to make my leading term, and then this will also create my middle terms I need. So now I just need my factors of positive 36 that add up to my middle coefficient of minus 13. So again here I'm going to get minus 4, minus 9. And if we check, we multiply these two, we get our leading term. This times this gives me minus 9x to the half, plus minus 4x to the 1/2, which add to 13. And then minus 4 times minus 9 give me positive 36 in the middle. So I have it factored. Now what I want to do is solve your factors. So I'm going to condense this step from before. That means set each factor with an x in it to 0 and solve those. So I'm going to have x to the 1/2 minus 4 equals 0. And then I'm going to have x to the 1/2 minus 9 equals 0. So to solve this one, I get x to the 1/2 equals 4. And the question is, how do I solve this now? Well, to solve, you always solve for the first power. So I'm going to square that. Okay, and I end up with x equals 16 for a solution. Now here, this gives me 9, and then I want to square both sides, and I get x equals 81. Okay, so I get two solutions, x equals 16, x equals 81 here. And the only thing that you want to do, and remember to do, when they're in quadratic form is to check. Check when they're square roots, check when they're original problems with fractions in them. That's where it gets tricky. If you do your work correctly, you don't have to check when these values are natural numbers. It's just when they become rational numbers, or when you're using fractions or negative exponents. So those can be trickier. So here, if I plug these in, if I plug 16 here, I will get the correct solution. I will get 0 equals 0. Okay? So then you also do that with 81. Okay, you could do a quick check on that. Let's do another problem. I do a rational one. And here, number 3, we want to do one that has negative exponents. X to the minus 2 minus 13, x to the minus 1. And we're going to use the same numbers, plus 36 equals 0. Okay, so again, we note this is quadratic in form because This is half. Okay, this exponent is half of my leading exponent, leading term exponent. And I have my constant. So again, I could go ahead straight to factoring this. So I want to create my two factors. And I want the numbers that multiply out to positive 36, but yet add to minus 13. So again, those numbers are minus 9, minus 4 in any order. And again here, I want to use my middle term, variable x with its exponent. And I want to make sure that these two multiply to my leading term. So x to the minus 1 times x to the minus 1 do multiply out to create x to the minus 2. So that's how we factor this quadratic form equation. Next step is to set each of these factors to 0 and solve them. So here what we have to remember is we have to remember how to solve negative exponents and remember the definition of negative exponents, that those are really fractions. So our next step is x to the negative 1 equals 9. And then to solve this, I could write this as 1 over x equals 9. Or I could raise this to the negative 1 power. So I could do it this way, or I could raise each side to the negative 1 power, because a power to a power, you multiply, and I just get x equals 1/9 as a solution. On this other side here, okay, if I raise both sides to the negative 1 power, I get the solution x equals 1 over 4. So here I have to check my solutions just to make sure they work. And in this case, I know they work, so I'm just going to go ahead and check them. But again, it's good practice to put them in there, especially when you have negative exponents, you have to. You put 1/9 in here, and you should get this side equal to 0, and the same with 1/4. Okay, so there's another type of quadratic form, and we'll do one more, and then you could practice these on your own. Okay, so the next one, number 4, let's do something a little trick here. Minus 13. And then what number we were using? 36. Okay, here's another that may not seem like it's quadratic in form, but we're looking for the pattern. This is a typical problem where we use substitution. Some books or some lectures will say, okay, let's let some other variable equal this inner part here, and then we could solve it like a quadratic. So let u equal x squared minus 4. Okay, so you can simplify this by letting this equal a variable and then back substituting to solve for that other variable. I'm just going to go ahead and tackle it right away as it is. I'm going to think, well, this is like an x squared, and this is like an x. So it's an equation that's quadratic in form. It's just that this x is this whole parentheses unit. Okay. So if I were to factor this, since I have extra parentheses, I'm going to use square brackets for my factor here. Factors. Okay, so if I use square brackets for my factors, what this means is that this gets split up into x squared minus 4 to the first power, like my middle term, x squared minus 4 to the first power here, And on the back, again, I want to find the factors of positive 36 that add to minus 13. I use minus 9, minus 4 in any order, and I have my factors. So you could straight out factor something in quadratic form like this. And now, just like before, I want to set each factor to 0 and solve. So here I would say x squared minus 4 minus 9 equals 0. And the other factor is x squared minus 4 equals 0. Okay? So I have it factored, and I can check my factors again, that they create the original equation, and they do. And now I solve each factor, and I get x squared minus 13 equals 0 here. X squared equals 13. Take the square root of both sides, and I get x equals plus or minus the square root of 13. Okay. On this side, I get x squared minus 8 equals 0. And then I'm going to square root both sides. First I bring the 8 over, take the square root of both sides, and I get x equals plus or minus the square root of 8, which, as we know, simplifies to x equals plus or minus, this is a 4 times 2, so 2 square roots of 2. And that's an acceptable format for my answer. So here I have 4 solutions, which is what you get. If you multiplied all this out, you'd have an x squared to the squared power. It would be an x to the 4th solution. So you can multiply all this out and then try to solve. But here, it looks like the format was very conducive just to factoring and solving. So that's my solution set here. So try to practice. There's a great variety out there. Do a few on your own. And the main thing is recognizing this format and relating it to quadratic form. All right, enjoy. Thank you.